All right, in this video, we're going to do EOC review number 14. This is Tuesday, April 20th homework assignment. So let's do a quick review. Do the following represent a linear or exponential relationship? So a linear is when we have a constant rate. Or a common difference. And our exponential relationship is when we have a constant ratio. And that can be growth or decay. So if something is growing exponentially or decaying exponentially, then we would have exponential growth. Okay, so if you're earning $150 each week, that's a constant rate, so that's going to be linear. If you're earning 4% interest annually on an amount invested, well, 4% is a ratio, so that's going to be exponential. A quantity tripling in value each week. Well, if you're tripling, then you're multiplying by 3 each week, which is going to be exponential. Bacteria growth. Well, if you know anything about bacteria, it grows rapidly. It doubles and doubles or triples and triples. So that is also an exponential relationship. And number 5, the cost of ordering X number of items. Well, you're going to be adding a value for each X number, which is a linear relationship. Okay, now we're going to look at number 6. 6, we're looking at a table, so we need to look at the relationship of our Y values. So if I'm going from 3 to 6, I'm adding 3. From 6 to 9, I'm adding 3. 9 to 12, I'm adding 3. So this is a linear relationship. And in number 7, to go from 3 to 6, well, that's what I just did in number 6, but I also noticed from 6 to 12, well, this is multiplying by 2 each time. 12 to 24, multiplying by 2. 24 to 48, multiplying by 2. So because I have a constant ratio instead of a constant rate, I have an exponential function. So how are linear and exponential functions different? Well, that's what I already wrote. Linear equals a constant rate or common difference. Think of an arithmetic sequence. And an exponential is a constant ratio. So we're multiplying by something each time. So something greater than 1, so multiplying by 2, or you can be decaying, which is multiplying by anything less than 1, like a half or a percentage. All right. Number 9, Lauren invested a principal amount, earning 8% interest. The graph that represents the situation is shown. What is the amount she invested initially? Well, the amount she invested initially is going to be $300. And I should do that in a different color besides yellow. Okay, her initial investment is $300. And I can tell that by looking at this graph and seeing where the y-intercept is, because the y-intercept is always your initial amount. What is the rate of growth? Well, the rate of growth is 8% or 0.08. What is the equation that could represent the situation? Remember our equation. So we'll put that as V. Our value of the account is going to equal our initial investment, the 300, multiplied by 1 plus the 0.08. So 1.08 is my growth factor. And that's going to be multiplied by T, which is the time in years. So after 10 years, how much money in interest will she have earned? So we're looking to see how much she's earned, not how much she has in the bank account. So we're going to do V of 10 is equal to 300 multiplied by 1.08 raised to the 10th power. And when we do 1.08 raised to the 10th power and multiply that by 300, we're going to get 647.68. That's the value after 10 years. But we want to know how much she's earned. Okay, so to find how much she's earned, we have to subtract the 300, which was her initial amount, and we get 347.68 is the amount earned. Okay, so understand the difference that this value is the amount in the bank account after 10 years, but the 347 is the amount she earned. Okay, number 10, does the following table represent a linear or exponential relationship? So again, we're comparing linear to exponential. Well, I'm going to look for intervals that are the same for my x. Okay, so if I'm looking for intervals that are the same, I see 10 to 5. That's a change in 5 years. And 5 to 20, that's a change in 5 years. So then I'm going to look at the change in y. Well, 610 to 673 is either plus 63 or it's multiplied by 1.1. And I'll write that in a different color. From 673 to 743, I add more than 63. Hang on. I did the calculation, but I wrote it down wrong. Is 70. And because those are not the same, I'm now going to check. And if I multiply by 1.1, I get about the same. But either way, because these common difference, that constant rate is not the same, I can determine that this is an exponential function. Number 11, does the top following table represent a linear or exponential function? Again, I'm going to look for the same change in x values. So plus 5 and plus 5. Here from 1530 to 1785, I added 255. And from 1785 to 2040, I added 255. Well, that is a constant rate of change. So this is a linear function. When you're looking at a table, make sure that you are looking at your x values change compared to your y values changed, because they won't always give you the constant change in both x and y. All right, that's it for EOC review number 14. I hope this helped.